let's move over to the calculus button and click on continuity and one-sided limits. And 12. We are moving right on down. Alright, so I don't know what this is. We're going to find out. Another one of these. Looks like find the limit. We got a piecewise function. And looks like we got to take the limit as x approaches 6 coming in from the right hand side of I of x. Let's move over to the whiteboard and scribble this sucker out. So we have I of x. Now, you know, you can name your function anything you want, so just to let you know there. What do we have? We have 9x minus 2. X is greater than 6 and 52, some constant, and it looks like x is less than or equal to 6, and I want to find the limit as x approaches, what are we approaching? I forgot. 6 from the right hand side of I of x. So if we're approaching 6 from the right hand side, we're going to want to use this one here because it says all x values greater than 6. All x values greater than 6. And if you can't see that, why don't we just go ahead and let me just sketch out, or at least get started. Get this thing started. Let's see, we'll put 6 right here for the heck of it. So we're coming in from the right hand side, right? So we're coming in from this direction. So that means we're interested only in the graph that's to the right of 6. Okay, so if we had an imaginary line here to the graph to the right of 6. Now that that is said, the limit as x approaches 6 from the right hand side, so I'm going to go ahead and write this in since this is the one we're using. We can go ahead and do direct substitution in this. 9, 6 minus 2. 6 times 9 is 54. Minus 2 is 52. Now that's actually interesting. We got a 52 there. Plug in 6, you get 52. Now we don't include 6, or we don't include 52. So remember that. And this graph actually is going to look something like this, I'll say. Looks something like that. It goes on, right? It goes on forever that way. This particular graph here is a constant. Of course, this is 52 right here, is a constant, and up until less than or equal to 6. So everything in that direction. Now, it says equal to, so we must include 6 right there. You see that? We have to include 6. Now, here's something about this particular graph. We can see that this graph, that this function is continuous. Okay, this guy's continuous, and this is obviously, this part of the function is continuous, but where they meet right here is what's really important. And it turns out that there are no breaks or jumps or holes in the graph, and we can just move right along this line and then move right along that line without having to do any kind of jumping, right? So this is actually continuous at 6. So I of x is actually a continuous function. So that's something that we need to add. We need to definitely add in all that. Okay, but really the question was, you know, what is this limit? And we said it was 52. Right. So there you go. Hit the answer, making sure our script is correct, and it is, and we're good to go. Alright, so you want to come over here, practice, and I'll see you there. Bye.